Hello, everyone.
Hi, everybody. My name is Antonio Ercole De Luca, and I'm introducing today our host, Laurent Picard. Am I right? I mean, am I pronouncing it right?
Yeah, it's okay.
Okay, maybe you should kind of lower your microphone, maybe because too high, too loud.
Okay. Is it better?
Try again.
Better?
Okay. Again.
Okay, let me listen. Any better now?
Yeah, but maybe there are some noise, kind of distortions. I don't know why, because of... Try again.
Okay, is it better?
No, I don't know if it's only on my side. I hope yes, but probably.
Okay, let me check. Because I've just said before, right before, there was no issue with sound. Any better now?
No.
Okay. Okay, let me try to. Okay, I join again. Yeah.
Perfect.
Okay, good.
Yeah. So here's Laurent Picard from Google Cloud. Is that correct? Okay.
Yes, exactly.
Yeah, is gonna introduce us building smart solution with no expertise in machine learning. So
great. Can you see my slides now?
Yes.
Okay, perfect. Let's get started. So we have 30 minutes altogether. Hello, everyone. Thanks a lot for having me today. We are going to talk about machine learning, but from the point of view of a developer. So my name is Laurent Picard. As you can hear, I'm French. You can follow me on Twitter at Picard Paris. And so quickly, I've been working in the past. I've been an ebook pioneer. I've been working on the ebook industry for 17 years. So I made one of the first ebook readers in '99 and created my own company since then. So maybe some of you know the Cybook device in Europe. And for 4 years, I've been focusing on cloud technologies, and I joined Google Cloud 3 years, a bit more than 3 years ago. And my goal today is to show you that you can develop smarter solutions. And when I do that, so I'm not an expert in machine learning, that's a bit of a contradiction, but when I do that, I still feel magic. Or when I see a new solution developed with machine learning, it really looks like it's a smart solution. And I feel like some magic. So I hope that maybe you'll feel some of it. This talk, I hope if you're an expert in machine learning, you will also learn something, because I'm going to try to show you a quick overview of everything that's possible to do without any expertise, or if you have expertise, how you can do it maybe a lot quicker or with better results. My own definition of machine learning is very peculiar, so it's not the right one, but the way I've been using machine learning for 3 years is the following. I have data, somehow any kind of data, and from this data, I want information. I want to understand what's in my data. So this is a wrong definition of machine learning. As most of you know, machine learning is actually a part of AI. And within machine learning, the field that is solving many solutions is deep learning. So when I'm mentioning machine learning, actually, I mean deep learning. But as I'm not an expert, I will just say machine learning. And anyway, machine learning, I think now is the generic term, the one that everyone understands. So how does it work? So first, at the origin, that was 40 years ago, some researchers have been trying to mimic the way we think, they thought our brain works with neural networks. For that, we need many examples, real-life examples. And the magic is that we now manage, since, let's say, a decade, we manage to solve problems with machine learning. We maybe don't exactly understand how we solve these problems, but we couldn't solve these problems before. And thanks to machine learning, it's now possible. Okay, why is it now possible? So first of all, we inherit from centuries of science, algorithms, and so on. Also for, let's say, 2 decades, we are now able to process big data. We're able to store a lot of data, and we have the computing solutions to process such big amounts of data. And for, let's say, about 10 years now, we are also able, thanks to cloud technologies, to process these algorithms and to process this data with top-of-the-edge algorithms in the cloud, and also with dedicated hardware sometimes, or GPUs. And thanks to that, now we have machine learning solutions that work, that are actually usable on a day-to-day basis, okay? So if we take a step back, there are 3 ways anyone can benefit from machine learning today. If you are a data scientist or a machine learning expert, you already know it all. You know how to build neural networks, okay? So you are rather on this side of machine learning expertise. But if you're a developer, you can use already trained existing models and through APIs. And you can do that with cloud APIs and sometimes also on Android or on browser APIs, okay? And filling a big gap in between expertise and pure developer skills, you can even build your own custom machine learning models now. And that's the big magic for a few years now. So this is what we call AutoML techniques. I think AutoML is catching up. This is a term now that many companies are using. And if you don't have expertise, or if you want to build something quickly with state-of-the-art machine learning techniques, maybe AutoML is the solution for you. So my goal in this presentation is to show you what you can do with APIs and with AutoML. It's a big field now. I've been doing that for a couple of years. It's always expanding, so I will go a bit quickly, and feel free to ask me questions after the talk. This presentation is online, so you can focus on what I'm saying. You will get the link at the end of the presentation. Okay. So let's get started with the APIs. So and how does it work? So I told you my definition of machine learning is that you have data. So this data can be text, pictures, videos, or even speech. And what you get from that, I told you, is information. You can understand what's in your text, pictures, videos, and sometimes also the information you want is actually your input transcribed into something else as an output. So here I will use Google Cloud Solutions as an example, but many companies have similar solutions, so you can retain the principles. Most of the time, they are available in many places, very often from cloud providers. And of course, there are also dedicated companies focusing on specific fields. I love to start with the Vision API because I am 47 and I was a student in the 90s. And when I was learning about how to do vision analysis in 93, at the time, the only thing we could do was edge detection with algorithms. And it didn't work that well. It kind of worked, but then when we would present our algorithms with new features, it would just fail miserably. So now a vision model is the perfect solution thanks to machine learning. So first of all, if you give a picture to a vision model, it can describe it to you with labels. So here I know that this picture, so it's a picture from New Zealand, where the Lord of the Rings movie were shot. This picture is about nature, flower garden, and so on. You get a confidence score. So yeah, it's nice, it works. Here it's the same picture, but I changed it. I flipped it. I changed the colors. I cropped it a little bit, and the machine learning algorithm is able to match it first and also map it to an existing location thanks to everything that's available publicly on the web. And here it's able to tell me where most probably, you see 61%, where most probably this picture was taken at. And that's correct. This is all between. It's still a place you can visit as a tourist. More precisely, if there are specific objects in the picture, it will give you the precise location of it. So here, so this is the cast, most probably at a restaurant. So you see, I know that there are persons. It's even able to tell me that they are tense or lower. There's a ceiling lamp here. Okay, next, more precisely, if there are faces, it will give you the location of the faces, and even will try to give you a sense of the sentiment for these faces. So here, this is a 3D rendition, so it's a very artificial picture, but still it's able to find a face in it, and tells you that most likely this picture is angry, and this is Gollum. Gollum is always angry red. We will do a demo all together, so keep your smartphones maybe connected. We'll do a demo with selfies of you if you'd like. Another problem that is now fully solved thanks to machine learning, and it was not the case before, OCR, optical character recognition. You can present a vision model with pictures where there's text, and it can transcribe your text or the picture, the pixels into text. It works at different levels, so it's able to find the different blocks. So here I have 3 blocks, the different sentences in the blocks, different words, and it also works at the symbol level, the letter symbol, the letter level. Okay, even if I apply some perspective effect on this picture, it still works perfectly. So now we can say that OCR is a purely solved problem thanks to machine learning. A more difficult problem is handwriting detection. And it works very well now thanks to machine learning. So it's the same kind of API. You can provide a picture with handwriting, and it will try to detect the different blocks. So here, ideally, I would have preferred a single block for the Lord of the Rings, but this is a kind of this is a layout like a poetry, right? But it almost makes no mistakes. I think there are 2 mistakes here. Here, shadows is shadows with a V, but yeah, handwriting is hard. So, and I could witness in over 2 years that the machine learning model improved and is, as of today, doing a bit less mistakes than before. Okay. Maybe the limit would be a doctor handwriting. You know, they write very fast, or maybe now they use a computer software. And finally, if there are famous entities, so a famous entity is someone or something that is publicly found on the web that you can crawl for, and you know, Google is good for it, then it will tell you so. So here, this is a unique picture that has been used once on a Spanish newspaper. And I took the picture, I flipped it, cropped it, zoomed in again, and changed slightly the colors. So there's nothing in common with the original picture. But it's able, like at the beginning with GeoPython, it's able to match the picture with something existing and tell me that likely this picture is about Tolkien, J.R.R. Tolkien. I get an identifier about it, and this is really correct. So this is matching this picture with an existing picture on the web, and of course the article that is next to the picture. You can also find matching images that are visually similar or that are partially similar if someone took a part of your picture, okay? So those are APIs, but you can use Python to use these APIs. There are open source client libraries that are wrappers to call the API online. And it's always the same principle, or at least in our case, you create a client, you provide the content. So here I want to provide pictures. So if I have two pictures here, then I can call face detection, and that's it. In most of the time, less than 1 second, I have my results. I can have hundreds, dozens of faces in my picture, and then I can parse here my annotations, my results, and do whatever I want with the results in these few lines. So this is also the magic here. You can do something very smart in a very small number of code lines. Okay. So similarly, there are models for videos, and you can extrapolate what you've seen on pictures with videos, but you have one more dimension, right? You have time. So for instance, it means you can also index your videos to know what you can find in your videos. So here, in this part of the video, there's a polar bear. So this is a similar use. As for pictures, here you get labels with the position in your videos. You can also track objects in videos. So here, this is a code sample from a tutorial I've written on the CodeLabs platform. So if you'd like to, if you're interested in tracking objects or finding out about all the different features about the Video Intelligence API, here, this is so the few lines needed to track objects. So like before, you create a client, you specify the feature you're interested in, you provide the content. So here, I'm, for instance, interested in some segments from my video. I give the URI of my video, and then I can call annotate video. Of course, here, the time you need to wait for the result depends on the length of your video. Roughly, let's say it will take half the time of your video to get results, and also it depends on the features you're asking. If you'd like to know more, I've written, you can follow me, or you can check out my GitHub repo, Cherry on Pie. I've written 2 articles about how to use, or about how to do something smart with videos. One of them is video object tracking, and you'll find so you'll find out an architecture, and you'll find many examples. So here, those are the main objects found in the video, and you'll also see how to generate small animations. And it's a project that you can deploy in 8 minutes, and the number of code or lines of code is 300 lines only. So once again, the magic is that in a very small amount of lines, you can do something very, very smart. Okay. Okay, I think, okay. So now the same with text. So you can provide text to a machine learning API, and you will get first, you can get the syntax analysis. So here, this sentence about Tolkien, the natural language API will tell me that this is an English text, and will give me the syntax with all the different types and natures of the different items, including the punctuation. So this is also a hard problem that is not now solved. Like in pictures, it will match and find entities. So here there are different classes of entities, and it finds three of them. In red are persons. Tolkien is a person. That's perfectly correct. And you will notice here that the ID I get here is the same identifier as before when I had a picture of Tolkien. Okay, so that is very convenient if I want to only use IDs and not strings. British is mapped as a location related to the United Kingdom, and the three books at the end are mapped as works of art. Perfectly correct. I can ask for content classification. So here, the same piece of text would be classified under books and literature at 97% of confidence. This is perfect. To give you an example, this is used by the New York Times, and they have classified hundreds of thousands of, millions now of articles, of legacy articles, of course, that they have scanned and OCR'd, and now they know you can find any article under specific categories. And finally, you can do sentiment analysis on text. So to try it out, I've used two reviews, one from the New York Times and one from a social network. The first one is positive, the second one is negative. And what I get on different text levels, so here, for instance, on sentences, I get scores between -1 and +1, and it does work. These comments come from the negative review of Pauline. She really hated the book. And these positive sentences come from the positive review from the New York Times. And of course, most of the time, there are many neutral sentences that you'll get also. This kind of natural language processing analysis is used by companies to know how people are talking about their solutions or products. So for instance, scanning tweets or web pages, blog posts, reviews, and they know and get alerts whenever someone is talking negatively about their products. It can be useful to filter out content about what you've done. Okay. Again, if you wanted to use that in Python, you create a client, you provide the contents or a document, can be plain text, can be HTML, and you can call analyze sentiment. And then you get the results at different levels with a score, a magnitude, and you can do whatever smart you feel like to do. Okay. Similarly, now translation is a commodity. You can do translations on text, any text, or almost any text, from over 100 languages to over 100 languages, thousands of combinations. This is Google Translate. I'm pretty sure all of you have used it. What I can share with you is that in 2016, I was not working for Google, but I was already using Google Translate for my own company. And I noticed that the quality went a lot higher in 2016. And I could understand what happened at Google with internal documents about it. There were also public communications about it. In 2016, Google actually switched the translation model from, let's say, a statistical model to a machine learning model. And thanks to that, the quality since then just kept improving and is giving very human-like results now. It just takes 2 lines of Python code. You create a client and you call translate, and you indicate the target language you'd like to translate the text to. Now, the 2 last APIs are about speech, either speech to text or text to speech. You can transcribe speech into text. It means you can index any audio stream where there's voice and understand what words are in your audio stream, at which location also. So very useful to index that. But this is also the core component of any voice assistant, right? You can speak to your assistant, your voice is transcribed into text, and the text is analyzed with the natural language API or similar, and then can even talk back to you. If you'd like to do that, I've written also another tutorial on the Code Labs platform, and where you can see how this is my own voice here with a French poetry that is transcribed into text. And the other part, the other side of the API is that now you can also generate a very human-like voice thanks to machine learning. So I will go, because of time, I will go a bit quick on this. I will just show you one demo. So you will hear my voice, but maybe not the result, but it doesn't matter. Okay, so let me search with voice, okay? I'm going to, so I am in English. Let me switch to English. And I'm going to try to speak in English, but with my French accent, right? What is the temperature in London? So you see, it worked perfectly. It's able to understand what I'm saying, despite my thick accent in French. And with the usual algorithms, it wouldn't work. So let me skip. Time is limited, so let me go to the next part. But you can do the opposite. You can I can actually speak French with a British accent, and it works also pretty well. If you're interested in sample code, those few lines allow you to generate sentences with different accents, Australian, English, and so on. Okay. So now let's move on to the other part, AutoML. So you've seen everything you can do with existing models, but sometimes it will not fit your needs, and AutoML is one solution, a great solution with that. Let me give you an example. From these two pictures, the vision model will give you almost the same results, because those are skies, those are clouds in a sky, right? But if you want to make the difference and know what is the specific type of clouds, then you can use AutoML, because there's no model that is able to do that right now. So for that, you need to do a bit more work. You need to provide training data. You need to provide pictures, for instance. And then you can use AutoML. You just launch a training, and it will train. Most of the time, you will need a few iterations. And once you're satisfied with the results, then you have an API. You can also build an edge model. It's a model that you'll be able to export and use offline, for instance, or use in your own containers, or use with TensorFlow.js in a browser. So many different use. So with my cloud example, so it's been done by a colleague of mine. She has used a couple of pictures of each type and labeled them, AutoCumulus and so on. She has launched a first training of 1 hour, then noticed a couple of mistakes, and then a training of 3 hours. And that's the final model she got. So she only had to label pictures and launch a training, and she can evaluate how well the model is doing. So here it's pretty great all the time, except for the AutoCumulus. The thing is that we have less samples of the AutoCumulus, and also they look much alike. So we should balance our data set a bit better and use more diverse. And then once the training is done, you can deploy it as an API. And just like before, you can use this API. This is your own private API. You can provide it with pictures, and then this is a picture of mine, never seen by anyone, and then it tells me there's a cumulus in the picture. Right. It works with pictures, videos, and text, and also structured data, everything that is tabular data. And as of today, but this is an ongoing field, and giving you many new features. You can do custom classification, custom object detection, and so on, even custom translation. So maybe this is something that can solve one of your problems. You can build your own model thanks to that. So we'll spend a couple of minutes. I've done an online demo to show it all. First, we'll use the Vision API, and then I've built with pictures of mine and some previous conference attendees, I've built my own AutoML vision model. So let's go directly to the demo. You can scan this QR code, or you can go to this URL, bit.ly/pyml20. Let me enable the demo. Okay. Again, so bit.ly/pyml20, or you can flash the QR code. Let me go there. Okay, you should see this page, and if you enable the webcam, then you can send self. Okay, so first, let's try to trigger generic emotions. Okay, so of course, this model has not been trained with pictures of mine. So here it's able to detect joy, able to tell me that I have a nose and a mouth, and so I can place a mustache in between. Now let's move to my AutoML demo. And if you, sorry for folks on YouTube, there is a delay, so maybe you will not be able to do that, but you will do the next part with AutoML because of the delay, okay? So here it's the same. It's the same app, but I'm using my own private AutoML demo, and I've trained it with people with their tongues out, people yawning, or right, and people sleeping. And let's try it. Feel free to stick out your tongue to me. Okay, so it's the same. The selfie is uploaded, faces are found, and it's calling my own API, and here it's able to find that I am sticking my tongue out. Let's have a look at the results. Hello, so a couple of people happy, myself. Hello, hello, someone surprised? Yeah, people with tongue out, it does work. People yawning, great. People sleeping, okay, so I was too boring apparently. And also, you know, it's able to find objects in pictures. So here we have people with glasses and with the precise locations of the glasses, okay. If you follow me, I'm going to publish this code in a few days, specifically how to use face detection. It will be on my GitHub repo also. So let's move on. Under the hood, so I don't have the time, but there are three main techniques. One that is known to the expert, transfer learning. One that is two that are specific to Google Cloud, machine learning for machine learning. So there's a meta layer of machine learning above to find the best machine learning architecture. And also now hyperparameters are found automatically. Okay, if you want to do more machine learning, if you want to become an expert, which I've not done because I'm in my 40s. If I were in my 20s, I would do this 100% of my time. TensorFlow is now a full ecosystem. It has become a standard. So, and it's also the favorite open source machine learning repo on GitHub. From researchers also, I hear that PyTorch is a very good framework. If you dive in, then you can do whatever you want. And maybe AutoML will be a complement. Okay, so let's summarize how can we build smarter solutions. So with the machine learning APIs, you just need a couple of hours. That's the stash demo I've done in one afternoon, how to put a stash below the nose. With AutoML, you need days to build a data set, right? And if you want to be an expert, then there are no limits. Some people are doing trainings for weeks. Here are the resources that you can use, and you will find more, as I said, on my Twitter and my GitHub. Okay. If you'd like to refresh your memories or learn about machine learning, here is a nice machine learning comic with many terms, and I learned a lot thanks to it. And here is my presentation if you'd like to get the slides, and if you'd like to get in touch with me or send me any feedback, you're very much welcome to do it. So thanks a lot for having me today. I hope you learned a few things, and my goal was also to give you a bit of inspiration. So I hope it gave you a few ideas. Thanks a lot for having me today.
Thank you very much, Laurent. That's awesome. I mean, what you presented today. I would say let's start with the questions. So Okay, I'm seeing someone is writing. Actually, there is someone who is already doing a question that I'm going to read. Hello, thank you for your presentation, Laurent. What is the difference between your presentation now and your presentation in 2018? And thanks for Fatem of Sahosei.
Yeah, so if you were at GeoPython 2 years ago, so that's almost the same presentation, but actually a lot changed. So first of all, AutoML has been developing a lot. You can have many custom features now. It's a lot faster. Algorithms, machine learning algorithms, just keep improving over the time. And also, all my samples with faces, with OCR, voice, and everything. As I said at the time, machine learning models just keep learning thanks to new examples. There's been a lot of work also on balance, how to remove bias from models. So basically, it's the same as 2 years ago, but better and bigger. I hope it answers your question.
Okay, so Assumption Termens, very interesting speech, Laurent, thank you. Panipulat, very inspiring speech, Laurent, thank you very much. Merci beaucoup, Laurent. And well, so maybe I should do one question. The AutoML feature that you just presented, I mean, it seems like it adds a new layer upon the feature that Google ML already, I mean, Google Cloud Machine Learning APIs already do. They already do. So how do you, this is awesome. How do you do that? I mean, do you use like neural network, deep learning upon the already made features, or do you use something simple like linear regression or something? I mean, what's behind that?
Everything that makes sense is used. So, for instance, for AutoML tables, where you provide tabular data, most of the time you will provide numeric data, right? But it also works on text. If you provide numeric data, then it will most obviously use regression algorithms, but state-of-the-art algorithms. But it also works on text, and then it will use natural language processing machine learning models under the hood. So it just picks up what's better. And what I've seen even over the last months is that sometimes there's something new, and you can search for research papers. So papers from researchers. There are many, every day there are new papers, and from something that can be used in production, I would say that every quarter, new algorithms are used in AutoML because there's something that can train faster, or that can give you, or that can give you better quality results. So yeah, it's very exciting because this is just the beginning, but with very little, very small data sets, you can already do something magical, at least in my eyes. And also what's interesting is that even for experts can build prototypes, or can just realize that something that they would need weeks to do can be done in hours or days. What I didn't mention is that also AutoML is very much computing heavy. It's using dedicated hardware for that. It's using TPUs. So historically, and still as of today, data scientists are using GPUs, not for gaming, but to do training and to do inference, to get results faster. So it still works, it's still up to date. But we have built dedicated hardware for that we call TPUs, Tensor Processing Units. So it's like GPUs, but dedicated. And there are also small chips that you can find on some smartphones to do local inference, local training, and local inference. And for instance, on the latest Android version, a custom model is built, learning from your habits, and is optimizing the battery life of your smartphone. So it's just the beginning. Our everyday life is really well getting easier thanks to machine learning. Most of the time we are saving time thanks to machine learning.
So I suppose that if you use TPUs, you are using deep learning basically in order to.
Yeah. Of course, most of this is deep learning, but whenever you have numeric data, then you will get into the field of linear regressions and so on. Yeah, it's a big field to talk about.
Next question is from Dimitris Politikos. Very interesting talk, thank you. I'm wondering how feasible is to use these tools to perform research on specific data domains, example, marine science.
I don't know what you mean by marine science. If you are talking about, I don't know, videos that you could take under the sea, then it's already being used by some companies to detect for, I don't know, if you want to inspect cables under the sea and find defects on cables, then so you can send robots and retrieve the videos, and you can teach a custom AutoML video model to find and detect defects automatically. So this is very useful. It's also used in the automobile industry or logistic industry to anticipate the maintenance. So for instance, to predict that in 2 weeks there will be most likely a failure in the engine on this particular, I don't know, train or truck. And so you can get a smoother and a maintenance process in big industries thanks to that. So the field is virtually unlimited.
Yeah, probably. I mean, you were mentioning industry, and maybe Mr. Dimitris, I mean, he meant like animals recognition. So it would be able, the algorithm, I mean, the tuned algorithm would be able to discern by different species of the same fish.
Yeah, so it's
a fish, but probably different species.
It happens that I think I have an example right here. Yes, so it's been done already 2 years ago. Not undersea, but on the sea. So here, this is the Zoological Society of London. So it's one of my tweets, and they've been working with Datatonic on a company, and what they are doing is that they are working worldwide in wild forest, right? And they want to understand how the different species evolve, which species are present in this wild forest, and how it evolves over time. So basically what they were doing in the past is that they would put cameras for 6 months, retrieve hundreds of thousands of pictures, and then come back, and then take 6 more months to process and analyze all the pictures with a lot of fake or wrong pictures and so on. With AutoML, they have been able to train a model. So they still spend 6 months to put the cameras and retrieve pictures, but now they just need 1 or 2 weeks, not 6 months, to automatically analyze. And those are the species, very detailed ones. So this could work for undersea species too, as you see. They have specified with labels, okay, this is a color red mongoose, this is a stink badger, I don't know this species, but very specific species. And AutoML is now able to find them out and make the difference in videos or pictures.
Okay. Last question, because we are already kind of out of time. Stefan, thank you for your interesting presentation. How good is NLP nowadays when using it for a reviewing system in terms of double negation, like this product isn't too bad? This is a specific question.
Yes, but actually that was a limit 2 years ago. So it's still kind of a limit. It's doing a little bit better, but the limit is sarcasm. The limit is the human limit, actually. So double negation is something that we understand most of the time. So it's doing better now. There are still some caveats, but sarcasm, you know, you are going 1 degree higher. So even humans most of the time are failing understanding sarcasm. They need to know the person or to have different hints. So I would say this is still the limit today. A natural language model based on machine learning is not able to understand sarcasm. it will take all the text at the first degree. So yeah, that's still the limit. For double negation, so there are some, you know, something that we could qualify as bugs. So some edge case examples. There's a few of them have been fixed over 2 years. Whereas new examples.
Okay, I hope that replies the question. So I thank you really much, Laurent. And well, for me, is my last introduction. So thank you very much and see you next time.
Thank you, everyone.
Bye. Bye, everybody.